morning, all. I'm Vaibhav. I work for Cisco as a part of the WebEx group. Basically, what I'm going to talk today is our journey of using Apache Pinot right from the inception stage, how we went about evaluating Pinot, and when we really got committed to Pinot, what are the open source contributions that we've been making across our team into Pinot. Okay, so this is what we are going to talk about today, which is the real-time observability using Apache Pinot and Grafana. And I know, seeing Grafana up there must be raising a lot of questions how we are doing Grafana, so I'll cover that in a bit. Okay, so before we dwell into the niceties, right, a bit about our team. So I work on the data and the analytics platform team for WebEx, and so I'm sure at some part of your professional journeys, everyone would have used WebEx at some point in time to have online meetings, right? So this is what is working behind the scenes. So WebEx, just to improve your experience with the online meetings, we actually are continuously monitoring a lot of media matrices, whether you guys are actually having issues or jitters and all those things. And all of that data is actually flowing into the data analytics platform. And so just why we are a big data platform, everyone would be aware of the 5 Vs, right, of the big data, so which is variety, velocity, volume, and veracity. So that is what actually fits in. So we have a variety of data, which is right from system stats to your media stats to basically what programs you're running in terms of CPUs, etc. So typically we handle around 100 terabytes of data per day. And at peak load, we could even get around 300 messages per second. So that is the peak load that the platform handles. Now, what really happened during the pandemic was all the online systems and the video conferencing systems, they were under load, right? And what it essentially means was everyone went online, everyone was having online meetings. And the questions that admins and our internal analytics analysts were asking completely changed. So there were jitters, all the customer admins wanted to know what was going on in their system. Suddenly they were bothered about what upgrade you've pushed, whether my jitters is because of the version upgrade that I've done, is it about too much of load on my network? So suddenly the number of dimensions on which customer admins wanted to do their analytics changed. And that actually posed a problem for internal SRE teams as well, because they wanted all these analytics available to them also, themselves as well, to actually answer the customer queries and all the things that were happening. And that is where we actually suddenly saw a rapid increase in the QPS of the systems. And obviously, since these were some of these features were customer facing, we required second latency and freshness of data. So imagine an event is going on, right? Your CEO is addressing a huge gathering, and suddenly you are like, I'm not able to hear him. What is the reason? The teams have to go ahead and fix that on the fly. So that is something that we were looking at with the changing landscape. Okay, so, the classic thing always is, and I think, most of us have been faced with this question is, right, whether you want to pre-aggregate or you don't want to pre-aggregate. And pre-aggregate actually seems to be one of the easiest ways to go. And how I actually classify this is, I'm a huge matrix fan. So, any decision that I take, I always kind of refer to the blue pill and the red pill analogy. So do you want the truth or do you want to live in the oblivion, right? So we actually picked the red pill. And we decided that we'll not go the pre-aggregate routes. We'll kind of go ahead and explore the things, whether we can do it in a OLAP database. And that is where we actually started our evaluation journey of Pinot. So just the test bed that we were using was the telemetry data, which is around 1 billion plus events a day. So the test bed had 30 days worth of data. It has 150 plus dimensions just for the test bed, but just to put things in perspective, we have more than 650 dimensions that are in play right now in production. This were already stored in Elasticsearch, and Elasticsearch was good enough for us before COVID when you did not have that much of dimensional analysis that had to be performed on the systems. And what we were doing, I mean, which is possibly anyone who's maintaining Elasticsearch would be doing, is rolling them up into a warm storage, basically move them from HTTP-based storage to HTTP-based storage to save cost. So this is something that we were doing before all of this was happening. And then obviously the big questions, right? And we started actually saying we'll not do pre-aggregates, we'll do runtime aggregates and look for a OLAP store. So this was our benchmarking process. So all the queries that we wanted to benchmark. So we picked up query patterns. I mean, obviously it's impossible to run every queries for benchmarking. So we actually picked up the query patterns that were most prevalent for answering such questions. So which was filter group by percentile queries. I mean, percentile is a huge thing, right? When you're talking about UDP packets, you really don't care about the exactness of the data, but you are talking about whether you are good enough. So approximations are good enough there. And obviously distinct counts. So this is what our results were, and we actually tested these results on concurrency. And we figured out, I mean, Pinot, so I won't go into I won't read the results through, but what we figured out was concurrency versus latency. Pinot was a low linear growth, and Elasticsearch was actually an exponential growth. And if you see, most of my things on the Elastic side are TO or NA, which is either they timed out and we were not able to run through a higher concurrency because the previous test results were not good enough. So these were some of the benchmarks. And actually, if you look at it, there's a benchmark for the distinct count where even Pinot was going to 10 seconds of querying. But what Karthik actually mentioned in his presentation, the hyperlog log. So if we actually shift to hyperlog log, this goes into sub-seconds. And I mean, instead of distinct count, you just do with the 99% accuracy there. Yeah, so this is just on a parallelism of 5, it's just drawing a comparison between Elasticsearch and Apache Pinot. So if you can see across all categories, right, Apache Pinot was doing good for us in terms of the runtime aggregates that we wanted. And that is where we actually started investing heavily into Apache Pinot. The other criteria that we observed, so this was just by the way kind of an observation. I mean, it was not something that was in our measuring criteria, was the storage. And which is what we saw is what we saw in our test results was there was at least a 10 times reduction in storage space. And yeah, I was talking to some of the folks just before this meeting that why this happened. And it's just a theory. I mean, I cannot be quoted or held accountable for this theory, but the theory there is, if you look at how Elasticsearch stores its documents, is more towards JSONs, right? All your columns are JSONs there. And when you talk about metric data, it's numeric, generally 4 bytes. You know, you won't be able to have that much of compression in place. But Elastic, the column names are stored with each leucine file. So a lot of space is actually taken by the name of the field itself than the data that you are actually interested in. And that is what actually, I mean, and I think so, some of the StarTree folks should confirm this theory, whether that is what is happening here or not. Okay, so where we are in terms of our implementation right now of Pinot. So from the POC phase, we've grown to a sizable deployment cluster. So we run a cluster of 142 servers. So that is across our largest data center. I've given the specs. So each of the servers have 28 CPUs, 128 gigs of RAM, and 3 terabyte of hard disk. The total volume that we have unreplicated is 121 terabytes in the cluster. So with the replication, it would be around 360 odd terabytes that we have in the cluster right now. And from the Elasticsearch, we have a saving of around 500 instances, mainly because of the storage compression that we got by using Pinot. So that is around, we were down from around 800 terabytes to 121 terabytes of storage. Okay, so these were the good things, right? We've shifted everything. We've done your external or user-facing analytics is taken care of because that is generally through your apps. But as I said, the second problem that we have were internal SRE problems. And when you come to those, these are fairly technical users, but they actually are very used to a particular tool set. So the obvious question that comes is, how can I explore my data? I mean, Elasticsearch has a fantastic way in which you can explore data. And to be honest, I mean, Elasticsearch is pretty good in what it does. It may not be good at the matrix analysis, but it is really good at log analytics. So, and traditional, I mean, operational folks are used to that. They are used to Grafana, right? So, I mean, an obvious question here would be, why not use supersets, right? Superset has a really good visualization across the Pinot, and it has a great integration with Pinot. Why not use supersets? So we actually went ahead and told our folks to go ahead and start playing around with superset. And they said, why are you making us basically learn a new tool? And with superset, what happens to my alerting framework? I mean, Grafana has a good alerting, so why are you forcing, what happens to my alerting? And superset, how I put it is more of a business analytics tool. You could compare it with something like Tableau, not really a observability tool in my opinion. Right, so what we started working on, and I'll jump into a quick demo for that. We actually started working on, so what we started working on in the background was how we could actually make the shift possible for even our operational engineers to use their old tool set that they were kind of very used to. And their old tool set was primarily around Kibana and Grafana. So we started actually building these two plugins. So for those who are actually aware of, Grafana can be extended to actually support your own data sources. So Grafana has this concept of plugins. So there are basically 4 plugins that Grafana supports. So we have developed the data source plugin and the app plugin for Grafana. So this is the data source plugin that we've built for Pinot. Again, this is not open source. This is ready for community review right now. We have not open sourced it as yet. So this is what we are doing. So it just takes the controller URL because, as you know, the brokers are actually discovered via the controller URL itself. So brokers are reachable, but all you have to do to configure the Grafana data source is the controller connections. Once you've actually gone ahead and configured the data source, this is how you can actually make a panel. So what we have is we have these support, which is time series, table support, and log support. Now, log support is right now not fully functional because this is something that we were exploring for CLP, whether we can use the decoders for CLP. So I know a recent connector came into Pinot for CLP, so we were just exploring that. But yeah, so this is how pretty much it looks like. You pick up your data source like you would do for anything like Prometheus or Influx. You, let's say, pick up a table sort of a format. You select a query that. So I'm just going to pick up my table as what I'm using for, sorry, monitoring my Pinot query data. So I pick up, let's say, the total documents that have been scanned. Just for the interest of time, I don't want to go ahead and make a full-fledged dashboard right here. And I run the query. Okay, so I don't want to pick up a time series. I want to pick up a bar chart. So this is how you would go ahead and you can visualize on the Grafana dashboard. Now, this is one of the options that we are giving, which is a builder option, which is more of a UI tool. But to be honest, this does not do justice to what Pinot can do for you. Because something like regex, something like division operations and all those things are not available through the builder option. So what we, and generally what we've seen, most of our platform users are actually using this code option. So you can actually go and write up any of your Pinot query here. And this would actually help you go ahead and satisfy and basically go and plot your Grafana graphs. So this is the first plugin that we built, which was the data source plugin. The next plugin that we have is kind of the Kibana view. So as I said, our internal operators were very interested in how I can go ahead and explore my data. So this is like you would have picked up a Kibana index. You go just see which environment, which Pinot table. This is the time, this thing, because that is required by Pinot to construct a series, right? So some of the features that we have been doing in this plugin. So you see something like Hex here. I'll be talking more about our contribution. I mean, this is still a development phase because JSONs generally take a lot of storage space in any of the systems, right? So we are actually hexing it, and how we are hexing and still at the same time using the JSON index feature that Pinot provides. So that is what we are using. So in this, you can actually see we have color coded JSONs and all those things. And something which is very useful in Kibana, right? You can just go ahead and add a filter from here. So all that is supported right now in this plugin. And similarly, you could go ahead, pick up table names, or let me not do table names, query time. So something like what, I mean, a Kibana interface has, wherein you can add columns dynamically and even the time support. So this is a app plugin that we have done right now so that you can kind of give it to your basically operators to look at the data and to visualize the performance data that you want. So these were the were the two things that I mean, two of the plugins that I actually wanted to demo that we are working on. Now coming to the open source contributions that we've been making in Cisco. So uh, if you look at previous to this bounded column value partitioner, we already had a modulo partitioner in Pinot, which was, but the problem with the modulo partitioner is uh, two of your systems can actually go ahead and evaluate to the same modulo. You may have skewness of data there, and it's not predictable. So what we did was a bounded value column partitioner, which is nothing but it's kind of a enum-based partitioning that you may want to achieve. So it's a more predictable partitioning scheme. So this was a part of the .10 release of Pinot. Then multiple column-based partitioning. This was actually a part of the .11 release of Pinot. So before this, Pinot used to just support partitioning on one column, and we had use cases where we had to do multiple column-based partitioning. The other where, I mean, you see a red dot there. So that is, so these two are already committed. The red dot in terms of partitioning is, we have not been able to kind of make it available for community review till now. So, but the backfill process enhancement that we've done. So traditionally, if you look at it, how backfills are done is, you do a backfill, you give it to your engineers to, or test engineers to go ahead and test whether the backfill has happened successfully or not. And then you actually, if it's not successful, you want to roll back, right? So this kind of a rollback feature was not, or rather is still not available in the open source Pinot version, because it is a straight off commit. So what we have done is we've kind of used the lineage feature that Pinot already has, and we have done some zookeeper enhancements here, so that you can actually achieve a rollback of the backfill that you want, or you do a commit and then you basically go ahead and discard the lineage that you have, so that it can be done in an atomic manner. Otherwise, your rollback would not be atomic, and you would see a bit of a downtime there. Now, on the visualization and alerting, I've demoed the two plugins that we have, which is the Grafana-based alerting feature and the Kibana plugin. On productivity, and this I'm sure most of you would have used this feature, is on the UI you have the user access feature that is there. So earlier to this, so this was I think so .9 or .10 version contribution. So earlier to this, what used to happen was you used to have users in your config files. You could not give dynamic user and dynamic permissioning to the Pinot files and to Pinot users. So that was a feature that we contributed on open source. Now, what we are actually even doing is all the Pinot connectors we are heavily contributing. So the Trino connector, we are actually doing a lot of bug fixes on the new gRPC support that Pinot has added. So our queries can be really faster here. And yeah, the next one is I already talked about the hex support that we are doing. So we leverage the JSON indexing that Pinot has here. But at the same time, we optimize the storage by hex. So, I mean, we are able to achieve a kind of 90% compression by using the hex-based storage for JSON data. Key-based dedupe. So, if you look at, so we briefly before this talked about minions, right? So Karthik was talking about minion. Now, when you are actually moving from real-time to offline tables via minion, you can actually put the scheme as a dedupe scheme. Now, dedupe, it actually happens on all the rows of, all the columns of that row. Now, if you want to go ahead and do just a primary case dedupe, that is not available. So that is ready for community review, and we should be able to push that pretty soon into the open source Pinot. And next is the rollup enhancement. So right now, what the minion rollups actually does is it's single column based. Sometimes percentile is not supported. So we are making enhancements on our local port. We've already done that. But again, we have not integrated it with minion right now. So that is why you see a red dot. We still are in the process of integrating that into, I mean, making it available for the community preview. Okay, thanks guys.